I'm here with another video again. Today I'm going to talk about the four main ways we can use Godot signals. Signals are a very important topic because signals are everywhere in Godot. They're how buttons know when they're clicked, how animations trigger events, how a game stays organized. In my short experience, I realized there are four main ways to connect and use signals. In this video, I'm going to try to break down those step by step. The four main ways are the editor connection, static code, dynamic runtime connections, and custom signals that you define yourself. By the end, we should know exactly when to use each method in our own projects. First of all, what is a signal? Well, a signal in Godot is like a message or an event that one object or node can send out to say, hey, I just did something, or something just happened. And other objects or nodes can listen for that signal and react to it. It's basically like events. It actually is like events in other programming engines. This way, nodes don't have to constantly check each other. They just subscribe and observe and wait for that signal from the event. What's important about signals is that it decouples the signal sender from the listener. The sender doesn't need to know about the listener. You can have multiple listeners. Many things can react to the same signal. For example, a UI update, a sound effect, an animation. And basically, you get cleaner code when you use signals. Functions only work between one sender and one receiver. But signals can have multiple receivers or multiple listeners, as we just said. So basically, if I have to give a one-liner about what signals are Godot's way of letting nodes say something just happened, so the other nodes can respond without directly telling them what to do. The first way I'm going to talk about is the editor connection, which is via the node tab. It used to be called drag and drop in Godot 3. In Godot 3, you were able to drag and drop the signal onto the nodes. That has been removed in Godot 4, well, at least in 4.41, which I use. So it's now using it via a node tab. Basically, you select a node, you go to the node tab, you click the signal, choose the target and the method name, and that's it. This is what I'm going to show you here now. So let's get right into it. So let me switch over to the 2D scene. As you can see, I already have a node 2D main scene here, and I renamed it signal scene, and I added a button. You can do the same. Let's just name this button something more descriptive so we won't get lost as we go along. And we're going to call this editor connection maybe, or editor button, editor connection button. And let's name it, let's just put that in the text of the button here, editor for editor connection, and we can save this. If we run this now, nothing will happen. Nothing is going to happen. As you can see, nothing is going on in the editor either. So let's give this some code. So let's connect this. This is the editor connection via the node tab. So we're going to click the editor connection button. Now remember, after we choose the target node, we have to give it a method name. So in order to have a method name, we need to have a script. I'm going to put a script on signal scene since it's a main scene. So let's just add a script here, and we leave it at everything default. We can probably remove process because we're not going to use that. We may use ready sooner or later, not right now. So let's go back to the left hand, the scene here, and click editor connect button, editor connection button. Go across into inspector, right next to inspector node. Double click pressed, and as you can see, this window comes up. It was connected via the node tab. We just click connect. It's going to put the method in the signal scene script that we just made, and there it is, function on editor connect button pressed. It creates its own name, sort of long, but at least it's descriptive. Let's remove the pass here, and let's give it a print so we can see something is going on. And we can say something like editor connection button clicked, and let's save this. And now this is going to run as we expected. When we click the editor connect button, at the bottom in the output here, we're supposed to see edit connection button clicked, and it works fine. So this is the first way. This is the editor connection via node tab method. It's good for beginners. It's good for quick prototyping and visual workflow. One major weakness is it's harder to refactor across scripts. Let's move on to the next one. This second method I'm going to talk about, it's a code connection. It's static, and you usually use it in the underscore ready function, but basically this is where we start calling the connection in the code rather from the node tab on the right side of the screen here. So let's add a new button. Let's rename this code connection button, and we're going to work from here. Okay, and being a code connection, a static connection in the code, we're going to write a code function. Let's just give it any name. Let's call it code connection button pressed, and we'll just give it another print. And sprint, we'll just say code connection button clicked or pressed or whatever you like. But this is the function we're going to call when we add the signal. Remember, I was saying that we usually connect the signal in the ready function. So let's create a ready function, underscore ready, func underscore ready, and let's connect it up here. And we're going to drag the code connection button in here, a reference to the button, and we're going to say when it's pressed. This is a built-in function. Pressed is a built-in function for buttons, and this is where we're going to do the connection. So we type connect, and connect requires a function. That is where we're going to put this function here, code connection button pressed. We're just going to take the name, not the open and close brackets, just the name. Let's copy that, Control C, and let's put it inside the connect brackets here, Control V. And that's it. We just connected. Whenever we press the code connection button, which is this button here, it's connected to the code connection button pressed function, which is this function here that we just created before. And that's it. So let's save this and play. Remember, it prints a function. I forgot to expand the button. Let's go back into 2D mode. This is the code connection button selected. We can drag it. Oh man. So let's just hold and give it some body and drag it across. And we can just give it a name, code con. At least we'll know which button it is. At least we'll know which button we're going to press. Let's save that. And let's run it now. So this is our editor button here. If we click this, we're supposed to see editor connection. And if you click the code connection button, we're supposed to see code connection button clicked. And we're seeing all that at the bottom here. So it works as intended. If you notice, when we use the node connection, there's a signal button right here. But when we use the code connection, the static connection in the code, we don't see that signal connection here. All we know is that we put it in the script. which is this function here, this call to connect, and this function here. So remember that you connect the button or whatever it is you're going to connect, the action, what you're connecting it to, which function you're connecting it to, and make sure you have a function to connect it to. It's that simple. The third main method is one called dynamic connection, also known as runtime or conditional signal connection. It's a little more involved because you only connect this when an instance of an object is created. So I'm actually going to create a new button scene. So let's click on the top here, the top tab right next to our signal scene, well, my signal scene, whatever you call it, right next to there. Click add, and we're going to add a button scene. So let's just click other node and search for button. Alright, there we have button recent, and I'm going to create a button there, and let's give it a descriptive name so we'll know what we are using it for. Let's call it we're going to instantiate this button or spawn it in the main scene. So let's call it spawn button, or if you want instantiated button, whatever name you'd like to give it. Enter, and let's save the scene. So now what we have to do, we have to write a function to instantiate or spawn this. Okay, so let's go to the top, and just to make things easy, remember if we put at export, we can actually see the item in the inspector. At export var button scene. We're just giving it a name. It's of a type packed scene. That's what this is called. Any scene that we've saved here, the TSC ends. Let me just drag this down a bit. Like this TSCN spawn button, TSCN signal scene. All those are known as packed scenes. So we're just giving this a name. All we want to do is to import the button that we just created, which is the spawn button .tscn. So we're just going to export it here. We can save this now. And if you click the signal scene and look on inspector, you will see at the top here now we have something called button scene, which is empty, and that is what we want to drag in. You can drag in or quick load or load or whatever you like. The spawn button does TSCN. You can just add it there, or you could just drag it across and add it like this. Okay, let's create a function to spawn the button. This is a very important concept which I may cover somewhere else. Let's call this spawn spawn button. This concept is how you'd like to spawn enemies, bullets, items, all these different things. You have a separate function that actually creates the item, and then you instantiate it by creating a spawn function or an instantiation function. In our case, we're spawning the button that we just created in spawn button.tscn. Let's just give it a name. Let's call this variable sp button for spawn button. Let's make that common. Just stick to convention. And this is of a type button, capital B button, equal button scene. That's what we created up here. And we're going to instantiate that, dot instantiate. And that's how we instantiate it. But all that does is just creates a variable of SP button. It doesn't place it anywhere. So we'll have to deal with placement, rotation, color, all those different things that we want when we instantiate the button. We can do all those things inside the spawn button scene if we add a script to it, or just create it using the nodes. For example, we can just change up the size, and yeah, actually we can just do that for now. Let's change the size of the button and inspector. So I'm going to go down in the layout and transform, and the size, let's give it a good size. Let's call it 150 by 50, maybe 40. So that's what our spawn button will look like. We can save this. If you want, you can give it other properties. Let's give it a name. Let's just call it spawned button for now. Let's save this. Let's head back to signal scene. We want to spawn these buttons maybe somewhere around here. And to keep things simple, I'm just going to spawn them one under the other. So let me just click the editor con button, and let's see where it is in the layout by clicking layout and in the inspector, transform, and the position. So it's at around 100 on the X position. So we can probably put maybe 100 in the X position of our instantiation code. But the Y value is what is important, because we're going to put them one below the other. So we've seen a Y value of 71 for this button here, so anything under that should be okay. So let's say 100 as well. So let's go back to the code and let's give this a position. So sp button dot position. Remember, it's a 2D scene, so we're using vector 2. And we said we're going to use 100 by 100, so our X value will be 100, but our Y value has to be below the other button. So let's say if we do 100 as well, it's going to be under the editor connection button. So we need to spawn this button. Let's go to the ready function at the top here, and somewhere around here we'll just call spawn button. That's going to spawn one button. But before we actually run this, all this is doing is creating an instance of the button, setting a position, but it's not showing the button. To show the button, we have to add something, a line of code that says add child, and the child will be the name of the button, SP button. Now if you run the code, we'll see the spawn button, but it's not in a very good position. So let's lower it a bit. I must have made some sort of miscalculation. Oh, that's why. We have the Y position, but I forgot to take into consideration that the button has height as well. So let's just put it at 150 for the spawn button. So let's go back to the code, and we'll make the Y value 150, and that should be fine. Run this again, and there we go. I want to spawn a couple more of these buttons because we want to show that each button that is spawned or instantiated comes with the connection as well. I'll add the connection in a while. I haven't gotten to the connection part as yet. So let's just spawn button maybe 2 more times. Control C, Control V, Control V. So this is going to spawn 3 buttons, but they're all going to be in the same position. So we just reposition them in a while. Let's just see. As you can see, they're one on top of the other, so we can't really see it. All we see that it's a little more darkened. In the Y position, let's find a way to add more Y position to this. Maybe we can add a count. At the top here, let's just add a variable button count. Type int, and let's initialize it as 0. And in the code here, every time we instantiate a button, let's add a count to it. So we'll say button count plus equal 1. So we're adding 1 to the button count value every time a button is instantiated. So what we can do now is every time a button is instantiated, we want to add a little space underneath the last value. So let's add button count, multiply by, let's give it a space of 50 pixels. And let's close off this. So what this is supposed to do, it's supposed to, the first button will be count 1. So that will mean it will be a y value of 150 plus 50, which is 1 multiplied by 50, and that's supposed to be 200. The second button will be 150 plus 100, and then 150 plus 150 for the third button. Let's see how it works. It works perfectly. So this is exactly what we wanted. Let's connect it up. Let's connect the signal now dynamically. Let's close this off. Before we add the child, let's add the connection. Remember, everything that goes into the button has to be before the add child statement. This is the actual dynamic connection here. Let me just put that here. Put some space. We're going to say button, SP button, SP button dot, when we press it, we want something to happen, so the action dot pressed dot, and this is where we do the connection, dot connect, and we have to connect the callable or the function. So let's create a function for when we actually press this button. So let's go below this function that we just created, and let's create another function, and we can call it spawned button clicked or pressed or something, and we can print again. Yes, my lovely typing, my lovely spelling. And since we have 3 different buttons, we're just going to say one of the spawn buttons was pressed. So let's say one of the spawned buttons was pressed. Close it off. And now we actually have a function that we can call. Control C to copy, and let's put it in here. Control V, and that's it. We actually wired up a button and connected spawn button click to it. If you notice, when we have the 2D view of the screen of the viewport, there is no spawn button here. And if we look at the scene block here, there's no spawn button inside this block, but it is created dynamically when we run the script. So let's just click run and see what happens. And let me just move this up here. So as usual, this one works, the editor connection button works, the code connection button works, and let's see if the spawn button works. Spawn button, one of the buttons was pressed, second one, it works as well, third one works as well. So it works as intended. So this is how we wire up dynamic connection to signals, and I'll move on to the next one soon. Let's close this off. Okay, so let's start working on the custom signal. Let's add another button. With this button, I'm not going to, let me just move it down here. I'm not going to directly change anything with the button. I'm just going to use it to move a color rect across the screen, and while that color rect is moving, it's going to emit a custom signal that we're going to make that will affect another color rect. It is the only easy way I can think of on the fly to illustrate custom signals. Let me just change the size of this button. Okay, and let's call this, give it a move box. Yeah. Save this. And let me just add a colorect. You know, colorect is my favorite. Let's move it down. I think I'm going to move my button up a bit. And the colorect, I'm going to resize. And what I'm going to do, every time I press the move box, I want this to move across. And I'm going to create another colorect. Control D. Let's move it up here. And maybe we can affect the color of this other box. So let's name the first box, just call it box, I guess. And the second one, we'll just leave it as color box, maybe. And that's fine. It's just to illustrate anyway. Let's go into the script now. Just for clarity, I'm just going to block all this code and comment it off. Control K. So as not to obscure our view and what I'm going to do next. Let's make sure we have no errors here. Good, nothing is working. Yeah, nothing is working. So nothing is working as it was before, so that's good. I just want to test that out. Let me go to the bottom of the function. We're not going to delete anything. We're just going to. So basically, let me start by creating a function that moves the box, the first box, every time I click the button. So let's click the button. I should name this to as move button or custom button. Let's just call it move button. Good. If I go into the node tab on the right hand side, I can double click pressed again and add it to our script. Every time we press the move button, I want to move our box, the first colorect, which we named the box. I want to move it to the right. So let's move it its x position plus equal, and let's say about maybe 100. So it moves to the right about 100 pixels. This is not a minus sign. This is a minus sign. Okay. And let's make sure it's working. I want to move to the right, not to the left. This should be plus. There we go. Right, and that works. And what we can do now, at the same time we click this button, we move its position, but we also want to create a signal that we can broadcast at this point. So this is where the custom signals come in. Let's go just above that function, which would usually be on the top of the whole script, just under the extend node. Let me just show you where I'm talking about. Yeah, underneath the extends node is supposed to be to the top. Anywhere under here, you can add your signals. Let's type signals. This is how you declare a signal. And let's just give it a name. We'll say box was moved, so we'll just say box moved to be more concise, and open and close brackets. You can put a parameter here, a typed parameter if you want. It can be an int, a string, it can be a colorect, it can be anything that you think you want to pass into the signal. But for now I'm just using an empty signal to make this easier to understand. Maybe later on we can go deeper into this, but not in this tutorial. This tutorial is just for a quick look at the 4 main ways to use. Now that we have the signal defined, we can easily broadcast it by calling its name, box moved dot emit, and it's as simple as that. If you did have parameters in here, you'd have to emit the parameters here as well. Let's just make sure the code is working and not broken. I don't expect anything to happen to the other boxes yet. Great. What I want to do is every time I click the button and the first box moves and the box moved signal is emitted, I want to change the color of the second box. So let's create a function that changes the color of the second box. It's not going to be used right away. But this is just to illustrate that you can use custom signals to effect some sort of change in any other node or object on your screen or anywhere else in the project. To make things simple, let's just drag the color box here and let's just change its modulate. If you remember modulate from another lesson, it's you can change the RGB and the alpha. We're just going to change the alpha, hence the .a, and every time we click the button and the box move signal is emitted, I want to, there I go again, I want to drop the alpha by, let's say, 0.2, which means by 5 clicks it's supposed to disappear completely. Now if we run this, nothing is going to happen again, but I just want to make sure there are no errors. Great. So this is where the magic happens. We have the signal being emitted, but there's nothing connected to the signal being emitted. Just as we did in one of the other examples. Let's connect it in the ready function. Our script is on the signal scene, which we are already in. Our signal scene here, that's the only script we have available for now. We're just going to connect this to the signal scene itself, so you can easily just type self.boxMove. Or since the script is already connected to the signal scene, we don't need to use the self because it's understood that whatever it's connected to it is by default affecting that node. So in this case, the signal scene, box move dot connect, and we just give it a name of the function that we want to call. In our case, it's a change color function. Control C, Control V. And that's it. There were older ways to do this in which you can you could have said, I'm just putting it for interest, you can say connect, and as you can see here, we connect the signal and the callable, which would have been open and close box move, comma, and the callable will be change color without the brackets. This would have been the old way to do it, but they both work the same way. This first method that I use is the latest Godot 4 method of connecting a signal. So let's just comment this out. Now this is supposed to work as we want it to. Every time we click the button, it's going to emit the signal as well as move the first box. When it emits the signal is connected to the script and it calls change color. When we look at the change color function, we see that it changes the color of the color box, actually the alpha of the color box in this case, by decreasing it by 0.2. It goes from 1 is full and it goes backwards. 0.8, 0.6, and so on until it reaches 0. Let's run this and see if it works. Click move box. If you look at the box on the other end, it's fading away. So this is how custom signals affect other objects or nodes on the project. It's quite useful because, as you know, box move is, if you look for box move signal in the built-in signals for Godot, you will not be able to find box move. We define this on our own, and we wired it up in such a way that it causes some sort of effect somewhere else. So this is how custom signals work in Godot. This is a introductory method on how to use it, but you can use it across nodes and across scenes, and of course it will be called upon a little differently if you're using it across different scenes, but it works the same way. There's something really cool I wanted to show. If we click the signal scene, wherever has the custom signal, and we go into the node tab, you'll see here for custom signal, it shows up at the top of the node list. Box move, our custom signal is at the top. This is what we defined here. It could be anything. It could be health change, it could be color change, whatever you want to define, it will show up at the top of the node list for that script that is connected to that scene. You can double click this just like any other built-in signal, and if we had another script, we can instantiate this in another script, or we can actually instantiate it in here. Let's connect it to the script and see what it looks like. So this script is automatically called when you use the signal box move. So on box move, and you can use this just as you did in the other examples. You pass in some thing to be done here, some change to be made here. When you move the box, when box move is emitted, you can actually connect. In this case, rather than have a change color function, I could have put the color box modulate A in the onBox moved and call onBox move where I connected the signal box move in the ready function here. I could have had box move dot connect on box move, and with the same code as in change color, and it will work the same way. There's just another concept I want to just mention here. It's called disconnect. Let me just do it to the editor connection button to make life simple. And okay, make sure this works for the editor button. Yes, in the output we see at the bottom here, editor button clicked, so we know that's working. Let's say for some reason we want to disconnect the click after we've clicked it once, or disconnect some sort of signal, maybe a custom signal, maybe a dynamic signal, whatever it may be. We don't want it to keep on firing. We can add a disconnect. So in this case, it's our editor connection button. Let me just drag this across. And of course, there'll be different ways that you can do this. In our case, we're just going to disconnect the pressed signal, which is a built-in signal, and type disconnect. And of course, we have to give it the name of the function. So Control C, and let's just put it in here. It's similar to connecting. And let's save this and run. What we expect to see here is we're going to get it to click once, and after that, it's going to disconnect because our function says it's going to print once, and then it's going to disconnect after that. So let's just press. If we notice under here, editor connection button clicked, and if you click again, it doesn't work anymore. So that's how you do this connection.